13.8 billion years ago, all of the universe was contained in a single point called a singularity. The point had infinite temperature and density, and was smaller than the size of a proton. Space, time, and the laws of physics as we know them didn't exist in this singularity. And then, it expands. The edges of the universe extend faster than the speed of light, growing by a factor of 10 to the 26th in just 10 to the negative 33rd seconds. As it grows, it cools down, but it's still too hot for atoms to form. Right now, the entire universe is permeated with a roaring hot plasma soup of quarks and gluons. As time passes, temperature drops. At 3 minutes, it's 2 trillion Kelvin. This is cool enough for quarks and gluons to combine to form protons and neutrons, and eventually the first atoms. First, it forms atomic nuclei of hydrogen. Those nuclei then combine to form helium and lithium. But these nuclei are ionized. It's too hot for them to capture electrons. All of the electrons in the universe are flying around freely, smashing into photons, which scatters light and makes the universe opaque. Nearly 50,000 years after the Big Bang, there's a key shift in the universe. Matter is now more prevalent than radiation. This means that clumps of dense matter can start to form. The seeds of stars begin to take root. A few 100,000 years later, the universe is finally cool enough for atomic nuclei to start capturing electrons. This means that electrons are no longer colliding with and scattering photons. The universe becomes transparent. Even today, we can detect light from this era. It's referred to as the cosmic microwave background. It's the earliest light we'll ever be able to see. Over the next 400 million years, the very first stars and galaxies begin to form. But you can't see them yet. This is because all of the hydrogen in the universe is absorbing the light emitted by these stars and galaxies. But stars continue to form, and eventually their high-energy photons begin stripping electrons from the atoms. The now ionized hydrogen stops absorbing light, and the universe emerges from the Dark Ages. Over the next several billion years, stars and galaxies continue to form, along with supernovae, pulsars, black holes, and other astronomical objects. Heavier elements forged in the bellies of stars. These elements go on to form other, denser celestial bodies, like the one we live on.